An LCD projector is a type of video projector for displaying video, images or computer data on a screen or other flat surface. It is a modern equivalent of the slide projector or overhead projector. To display images, LCD projectors typically send light from a metal-halide lamp through a prism or series of dichroic filters that separates light to 3 polysilicon panels, (1 each for the red, green and blue components of the video signal. As polarized light passes through the panels, individual pixels can be opened to allow light to pass or closed to block the light. The combination of open and closed pixels can produce a wide range of colors and shades in the projected image. Metal-halide lamps are used because they output an ideal color temperature and a broad spectrum of color. These lamps also have the ability to produce an extremely large amount of light within a small area. Current projectors average about 2,000 to 15,000 American National Standards Institute lumens. Other technologies, such as digital light processing and liquid crystal on silicon, are also becoming more popular in modestly priced video projection. Projection surfaces, because they use small metal-halide lamps and the ability to project an image on any flat surface, LCD projectors tend to be smaller and more portable than some other types of projection systems. Even so, the best image quality is found using a blank white, gray, or black surface, so dedicated projection screens are often used. Perceived color in a projected image is a factor of both projection surface and projector quality. Since white is more of a neutral color, white surfaces are best suited for natural color tones. As such, white projection surfaces are more common in most business and school presentation environments. However, darkest black in a projected image is dependent on how dark the screen is. Because of this, some presenters and presentation space planners prefer gray screens, which create higher perceived contrast. The trade-off is that darker backgrounds can throw off color tones. Color problems can sometimes be adjusted through the projector settings, but may not be as accurate as they would on a white background. A projector's throw ratio is used when installing projectors to control the size of the projected display. For example, if the throw ratio is 2:1 and the projector is 14 feet away from the screen, then the display width will be 7 feet. History: early experiments with liquid crystals to generate a video image were done by John A. Van Raalte at the RCA laboratories in 1968. His concept was based on E-beam addressing to generate an electronic charge pattern corresponding to a video image, which in turn controlled the LC layer of a reflective LC cell. Jean Dugu began thinking about different types of projectors in college in 1968 as a way to produce a video projector that would be brighter than the then available CRT projectors. The idea was to use elements referred to as light valves to regulate the amount of light that passes through it, such as in traditional slide projectors. This would allow the use of a very powerful external light source. After looking at many different materials, he thought that liquid crystals would allow to modulate the light as planned. However, direct-driven, matrix-addressed LCDs with sufficient resolution for video images were not available at the time, so that Dugu could not yet do experiments. First experiments with a direct-driven, transmissive matrix-addressed LCD and a converted slide projector were done by Peter J. Wild working at Brown Boveri Research, Switzerland, in 1971 and demonstrated at the SID Conference 1972 in San Francisco. As passive LCDs were not capable of displaying images with sufficient resolution for video pictures, a combination of a fixed image together with an LCD matrix for the variable elements was proposed as an LC projector for certain control room applications, with a corresponding patent filed in Switzerland on December 3, 1971. A lot of effort went into optimizing thin-film transistors suitable for driving active matrix-addressed LCDs. The concept was invented and early trials were conducted by teams at RCA and Westinghouse Electric. Peter Brodie left Westinghouse and founded Panelvision in 1981 to manufacture AM LCDs. Breakthroughs occurred elsewhere in new materials and thin-film structures, with Hitachi of Japan as a pioneering company. Such AM LCDs became commercially available in the early 1980s. Therefore, it took Dugu until 1984 to get a digitally addressable LCD matrix device with sufficient resolution, which is when he started experimenting with an LCD video projector. After building it, he saw many problems that had to be corrected, including major light losses and very noticeable pixels. He then invented new optical methods to create high-efficiency and high-brightness projectors and invented depixelization to eliminate the appearance of the pixels. With patents all around the world, he started Projector Vision, Incorporated in 1988, the world's first dedicated LCD projector company, which he took public on Nasdaq in 1990. He licensed the technology to other companies including Panasonic and Samsung. This technology and company advanced the digital video projection industry. Early pioneers in Japan were Epson and Sharp, which launched their own color video projector products in 1989. In 1989, Projector Vision, Incorporated was awarded the first Defense Advanced Research Projects Agency contractor €1 for $1 million €1 for proposing that the United States high-definition television standard should use digital processing and projection. As a member of the National Association of Photographic Manufacturers Standards Subcommittee, IT7-3, Dagu along with Leon Shapiro, co-developed the worldwide ANSI standard for measurement of brightness, contrast, and resolution of electronic projectors. Since 2005, the only remaining manufacturers of the LCDs for LCD projectors are Japanese imaging companies Epson and Sony. Epson owns the technology and has branded it as 3LCD. To market 3LCD projector technology, Epson also set up a consortium called the 3LCD Group in 2005 with other projector manufacturer licensees of 3LCD technology that use it in their projector models. Early LCD systems were used with existing overhead projectors. The LCD system did not have a light source of its own. It was built on a large plate that sat on top of the projector in place of the transparencies. This provided a stopgap solution in the era when the computer was not yet the universal display medium, creating a market for LCD projectors before their current main use became popular. This technology is employed in some sizes of rear projection television consoles, as there are cost advantages when employed in mid-size sets. Another advantage of using this LCD projection system in large television sets is to allow better image quality as opposed to a single 60-inch television, although in 2006, an equal of an LCD projector is the LG 100-inch LCD TV. Still in prototype stages, this television is a huge advancement towards projector-sized televisions. A common rule of thumb is that in LCDs image quality will decrease with a size increase. A workaround is to use a small LCD panel and project them through a lens onto a rear projection screen to give a larger screen size with a decreased contrast ratio, but without the quality loss. In 2004 and 2005, LCD front projection was enjoying a comeback because of the addition of the dynamic iris, which has improved perceived contrast up to the levels of DLP. The basic design of an LCD projector is frequently used by hobbyists who build their own DIY projection systems. The basic technique is to combine a high color rendering index high-intensity discharge lamp and ballast with a condenser and collector Fresnel lens, an LCD removed from a common computer display and a triplet lens. See also. Notes. References: Powell, Evan. Epson 730C, Best of Class in 2000 Lumen Portables, ProjectorCentral.com, Business Wire. Leading projector manufacturers Fujitsu, Hitachi, Panasonic, Sanyo and Sony join forces with Epson to educate the market about benefits of 3-panel, liquid crystal display technology, ProjectorCentral.com, Lawler, Richard. LG's 100-inch LCD set for mass production, Engadget, Breeden, John. LCD monitors go big, with mostly good results, GCN, PA3, external links, Throw Rataya article on projector throw and display size ratios. LCD projectors versus DLP projectors Easy guide on LCD and DLP technology in projectors and how they compare, 3 LCD projector technology, further reading, Fischetti, Mark. 2 technologies shine. Scientific American PPA 110 111. Two technologies are micromirrors and liquid crystal displays have been vying for these markets, but they are doing equally well in today's home and business areas.